This video will explore how to use syllogisms, a form of deductive reasoning, as a logical bridge in your science fair project. A syllogism allows you to move from established scientific theories to a specific, testable hypothesis. Understanding the syllogistic structure is crucial. It consists of three parts: a major premise, which is a general rule, a minor premise, which is the specific case you are testing, and a conclusion, which is your predicted result or hypothesis. You can use this structure to formulate a hypothesis. For example, the major premise is that all plants require sunlight for photosynthesis. The minor premise is that a bean plant is a type of plant. The conclusion, or hypothesis, is that a bean plant will require sunlight to grow. Hypotheses are often written in the if-then logical structure. This is essentially a conditional syllogism that connects a cause, the condition, to an effect, the prediction, based on an observation. Syllogisms are also used to validate your conclusion through the CER method, claim, evidence, reasoning. The reasoning step is where you use a syllogism to logically support your claim with the evidence collected. Understanding syllogisms helps you avoid common logical fallacies. These include the undistributed middle, using 4 terms instead of 3, or affirming the consequent, which is confusing cause and effect. A valid syllogism must follow the rule of 3 terms: major, minor, and middle. This principle ensures that you use exactly 3 distinct terms consistently, maintaining logical clarity throughout your reasoning. Here is an example for a soil pH project. The major premise is the general requirement for clover. The minor premise is the specific pH of your experimental group, and the conclusion is the predicted outcome for the plants in that group. To ensure sound logic, check that your middle term covers the entire category. Avoid using 2 negative premises, and check for quote, 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 quote. Let's apply the syllogism to rubber band elasticity. The major premise is about how heat affects polymers. The minor premise identifies the experimental group as polymers subjected to heat. The conclusion is the predicted increased flexibility. To verify the argument's validity, ensure you use exactly 3 terms. Distribute the middle term by making a statement about all members of that category, and ensure quality matching between premises and conclusion. In summary, the major premise is supported by background research on polymer chains. The minor premise details the experiment setup. The conclusion is the testable hypothesis that warm bands will stretch more under the same weight. The most common formal fallacy is the undistributed middle. This happens when the middle term, like stretching, is not specific enough to connect the major and minor premises, leading to an incorrect conclusion. Use this summary checklist to double-check your project's logic. Watch for the fallacy of 4 terms, the undistributed middle, exclusive premises, and overgeneralizing your conclusion.